Sorry for all the interruptions. I thought this. Okay. All right, so what we're going to do is look on the board. Now that may seem pretty simple what's up there, but it's important to what we're going to be doing. Remember, we're going to enjoy the easy things, the simple things, because not every day is simple, and so we want to enjoy this while we can. All right, all this is asking us to do is to practice counting forwards and backwards, skip counting. Here we've got the 2s, the 3s, the 4s, and the 5s. And realize that skip counting helps you with multiplication, doesn't it?
Yeah.
This is actually 2 times 1. This is 2 times 2. This is 2 times 3. 2 times 4, and so on. 3 times 1, 3 times 2, 4 times 1, 4 times 2, 4 times 3, 5 times 5, 5 times 6, 5 times 7, 5 times 8. So if you know how to skip count, that's why you start skip counting when you're probably... when I taught kindergarten years ago, I remember skip counting a little bit in kindergarten. So you might, I don't know what, pre-K, maybe? I don't know. So that's why you start doing this really young, so that you've got it really well learned as you get older. So let's do this. We're going to go forwards and backwards. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Let's go back. 20, 18, 16, 14, 12, 10, 8, 6, 4, and 2. I think there's a lot of people that are pretty fast with counting by 2s. All right, 3's a little bit slower. Here we go. 3,
6,
9, 12, 15, 18, 21, 24, 27, 30. Let's stay together. Okay. 30, 27, 24, 21, 18, 15, 12, 9, 6, and 3. Okay. It helps that it's in front of us. If we had to do this without it up here, it would be a little slower probably. Here we go. 4s. 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. 40, 36, 32, 28, 24, 20, 16, 12, 8, 4. Okay, one more. The 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Let's go back. 50, 45, 40, 35, 30, 25, 20, 15, 10, 5. That's the one I remember in kindergarten. We'd go 5, 10, 15, 20, 25, 30. We'd go all the way to 100 almost every day.
Yeah.
You know.
Now I remember that.
Counting to 100 is a big deal in kindergarten. Big deal. Okay. Now, these kinds of things are going to come in handy and be helpful. Your multiplication facts are going to come in handy and be helpful when you do division. Okay. And we're going to see that especially today. I don't see one up here before they jump into the lesson. Go ahead and get out your whiteboards, because I'm just going to have to add some things today on another screen to give us the practice that we need. At least for a while, I want to give us 1 or 2 multiplication problems to do every day, because that's fresh, it's new, it's a brand new skill, and we don't want to lose it. So we're going to make sure we practice that too. Okay, so if you'd put that on your board, go ahead and work that out. Catherine.
She was just screaming.
Miss Elizabeth was reenacting something. She was just making sure they didn't
We heard chicken
find
nugget.
something.
We heard chicken nugget. She was just screaming.
Alright, everybody's okay.
I thought something happened.
Alright, as you finish that up, I'm going to get started with it. And I want you to check your answer. Okay, some of you may already be finished. 6 times 9, 54. I'm going to put the 4 and carry the 5. 6 times 2,
12.
12 plus 5 more. So 13, 14, 15, 16, 17. Put the 7 and carry the 1. 6 times 3, 18. One more, 19. Put the 9. Carry the 1. 6 times 7, 42. Plus 1 more, 43. Okay, 43,974. Anybody get that? Several? Okay. If you did not get that, do you see where you might have made a small mistake? Anybody brave enough to share that with us?
Instead of a 3 or 42, I put a 2 on there.
You probably had in your mind 6 times 7 and just didn't add in that last little 1. And that's a very common mistake where we forget to add in those things we've carried over. It happens all the time. But sometimes if we say it out loud, talk about it, realize what we've done, it might keep us from doing it the next time. Okay. Anybody else have anything they want to share? Okay, even just doing one of these a day will help us get stronger. Okay, even if down weeks from now we're doing something totally different, but we do one of these every day, we're going to keep getting better at it. If this is something that you're not super strong with, do one and ask your folks now, hey, write me a multiplication problem. Let me work it out and you check it for me. You know, I don't mean you pull out a calculator and do it. That doesn't help you. Okay, but see if you can check it with a calculator. See if you get the same answer. You know, it's a good way to use your calculators to check it. Okay, so let's keep moving. I'm just going to borrow the problems from our chart today. Why did I do that? That's one way to erase the board, but it didn't even erase the board. Okay, so go ahead and put the top on your marker. Go ahead and lay it down. Okay. Go ahead and lay it down. Now, when we have talked about division, the little bit that we've talked about, we have so far talked about 2 ways to do it. If we had a problem like this, we're going to start off super simple here. I don't want you to write anything. Okay. If we started off with that, well, first of all, you might immediately see a fact family in there. What numbers go with 6 and 3?
2.
2. Okay. If you didn't notice that right away, what are 2 ways that we've talked about that you could figure this out? Yeah.
Multiplication.
Multiplication, okay. Thinking of your fact family. 3 times what is 6? All right, so you might go 3 times 1. We know that's 3. 3 times 2. There we go. That one was pretty quick to get to. Sometimes you need to do this and get as close to that number as you possibly can. What if we had the problem 7 divided by 3? And that's not a fact family. And so if we use multiplication like Mason mentioned, we might need to look at, okay, 3 times 1 is 3. But I think we can get closer to 7. Let's try 3 times 2. We know that's 6, and that's very close. But what if you're not even sure then and you go, oh, let me try for the 3 times 3. Let me see if I can get closer.
No.
Okay, what are you going to realize at that point?
It went over.
You went over. I'm glad you're seeing that because we need to have that understanding that we can't go over the number. That's way too large, isn't it? Way too big. So we would stop right here.
And the remainder would be 1.
Okay, and when we take 6 away from that, we would have 1 left over. Okay, so multiplication. What's that way we used a lot yesterday? What did we call what we did yesterday?
Marshall.
We drew a lot of dots, I know that. What did we call that? An array model, however you pronounce it. Let's do that for up here. And y'all remember, an array is just rows of some sort of shape. It could be triangles, it could be stars, it could be dots, it could be squares, okay? And we're going to put them in groups of 3. 1 group of 3, 2 groups of 3. So our answer is 2. Here, what's nice, really nice about an array, especially if you're learning about remainders and you're not real comfortable with remainders yet, if we put 7 dots and I circle my groups of 3, it's real easy for me to see my remainder. Okay, real easy to see that. So we would have 2, remainder 1. We didn't finish that answer, did we? Okay. All right. So we've got arrays and we've got multiplication. Now multiplication is going to be definitely handy in the next few days to help us. We're going to stop here for just a second. We're going to watch, this is the same video that you watched at home the day that we did our distance learning day. It's been a little while since then, and so let me pull it up. But this is a really good, well then this would be good for you to see because this is a really good, just very basic about division video. Let's find it. Where is it? There. It's about 10 minutes. 9, yeah, right, almost 10 minutes. Now it's going to start off very basic with some array type things, some multiplication, but then it's going to start showing you the very beginnings of our long division that we're going to start today. So I really want you to pick up on that. Okay. All right.
Hi, and welcome to Math Antics. In this video lesson, we're going to learn the basics of division. And if you really understand these basics, then it'll make it much easier learning how to do long division, which is the subject of our next video. Okay, so here's how basic division works then. You get a problem like this one, 9 divided by 3, which means you have a total of 9 and you want to divide it into 3 equal groups. And if you can remember that 9 is an answer to one of the multiplication facts, or that it's an answer on the multiplication table, then you can see that since 3 times 3 is 9, then 9 divided by 3 is 3. It's that simple. Well, at least it was that simple when you learned about the fact families. Now it's going to get a little bit tricky because most division problems aren't quite this easy. Like this one, 9 divided by 4. The trouble here is that 9 and 4 aren't part of a fact family. So you can't just find the answer on the multiplication table. That's because 9 is not a multiple of 4. There's no whole number that you can multiply 4 by and end up with 9. That means that 9 can't be divided equally into 4 groups without having something left over. Like if you had 9 cookies and 4 kids. Each kid could have 2 cookies, but there would be 1 left over. And in division, that leftover amount is called the remainder. So the answer to 9 divided by 4 is 2 with a remainder of 1. Alright, so it's not that hard to figure out a simple division problem when you have a picture like this. But what about when we just have numbers? To do that, we use a special division procedure. Up until now, you probably have used this division symbol the most. It works well for very simple division problems, like the ones in our fact families. But now that we're going to be doing some harder problems, we need a new division symbol. This one. This division symbol is special because it's almost like a stage that will help us solve our division problem. And there's 3 special areas of this stage where the 3 main parts or characters of our division problem will go. The first area is here under the long horizontal line on our division symbol. This is the area where we put the number that we'll be dividing up. The fancy math term for this is the dividend. Most of the time the biggest number will go here because we usually start with a big amount and want to divide it into smaller groups. The second area is out in front of the curved part of the division symbol. This is the area where we put the number we'll be dividing by. The math term for that is the divisor. In other words, this number will tell us how many groups we'll be dividing our big amount into. And the third area is up above the horizontal line. This is where our answer will go once we figure out what the answer is. The answer to a division problem is called the quotient. The answer tells us how many we'll end up with in each group. So whenever you have a complicated division problem to do, the first step is to rewrite your problem in this form. If you have 9 divided by 4 like this, you put the 9 down here, that's the number we're dividing up, and you put the 4 out here, that's the number we're dividing by. And you're ready to start the next step of the procedure. The next step is the most important step, because it's where you figure out the answer. And to figure out the answer, which is how many you'll end up with in each group after you divide, you have to ask yourself a really important question involving the other 2 numbers. The question is, how many 4s will it take to make 9, or almost 9? And the key to answering this question is for the number to be just right. Do you remember the story of Goldilocks and the 3 bears? How one chair was too big and one chair was too small, but the other chair was just right. Well, it's the same way with our division problem. If I choose an answer that's too big or too small, it'll cause trouble for me. Here's what I mean. Let's say that I decide that I only need 1 4 to make 9. So I'll write a 1 up here in the spot for the answer. Well now, the next step in the procedure is to multiply that answer I put there, the 1, by the number of groups out front here, the 4. And I write the answer to that multiplication down below the number I'm dividing up, the 9. I do that so I can subtract that amount from the 9 to see how much I'm going to have left over, to see how big the remainder will be. And when I do that, I see that 9 minus 4 will give me 5. That's a pretty big remainder. In fact, the remainder is bigger than the number I'm dividing by, and that's why this answer is trouble. If the remainder is bigger than the number you're dividing by, it means that you should have picked a bigger answer, because each of the groups you're dividing up into could have gotten more than they did. Your answer was too small, and so the remainder was too big. Okay then, I guess I'd better come up with a better answer to the question, how many 4s will it take to make 9, or almost 9? This time, I think I'll pick 3. So, I put a 3 in the answer space, and then I follow the next step of the procedure like I did before. I multiply the answer I chose, 3, by the number of groups, 4, and I write the answer to that multiplication problem, 12, down below the number we're dividing up, the 9. Now, I can subtract that number to see what my remainder will be. Or can I? This looks like trouble again. The answer to my multiplication is bigger than the number we're dividing up, so I can't subtract it. The remainder would be less than 0, and I can't have a remainder less than 0. That can't be right. Here's the problem. When you choose an answer that's too big, it's like trying to give too many to each group, and then you run out of things to give before the groups are equal. And if the groups aren't equal, they get all upset.
And then if they get all upset, they start fighting. They start fighting. They get in trouble. They keep trying to
Okay, so 1 was too small. It gave us too big of a remainder. And 3 is too big. There wouldn't be any remainder at all, and the groups wouldn't be equal, which causes big problems. So let's try 2. If we say that 2 4s will make 9, or almost 9, our problem looks like this. 2 goes in the answer spot, and then we do our multiplication procedure. We multiply that 2 by the 4, and we get 8. Then we write the 8 below the 9 so we can subtract it and find our remainder. 9 minus 8 equals 1. So that means our remainder is 1. Now that sounds good. It's less than our number of groups, and you can see with our cookie problem that it's exactly right. 9 cookies divided into 4 groups gives 2 cookies to each group, with 1 left over as a remainder, which we'll put right up here in our answer with an R for remainder. Perfect. And now you can see how you can do division without using pictures or cookies, but just with numbers and a procedure to follow. Let's try a couple more so you really see how it works. Let's try 23 divided by 5. We start, as always, by making sure our problem is written correctly using our new division symbol. The 23 is what we'll be dividing up. It's our dividend. So we put it under the line, and the 5 is what we're dividing by, our divisor. So it goes out front. Okay, so now we ask, how many 5s will it take to make 23 or almost 23? Well, 1 5 would be way too small. 2 5s is 10, that's also too small. 3 5s would be 15, 4 5s is 20. Oh, that sounds promising. Now 5 5s is 25, and that would be too much. So it sounds like 4 is a really good number to pick for our answer. So let's put that on the answer line. Next, we need to do the step where we multiply the answer, 4, by the number of groups, 5, and we get 20, which we'll write below the number we're dividing up, 23. Now we subtract those numbers to see what our remainder is. 23 minus 20 is 3. Well, that's good. 3 is less than our number of groups, so it's a reasonable remainder. So our answer to 23 divided by 5 is 4 with a remainder of 3. Let's do one more before you try working some out on your own, okay? Let's do 57 divided by 6. First, we set up our problem, and then we ask the question, how many 6s do we need to make 57 or almost 57? Well, this one's a little more tricky, so I think I might use a multiplication table to help me out. The nice thing about a multiplication table is that it shows me all the multiples of a number. For example, since I want to know how many 6s I need, I can look on this row of the chart and see all the multiples of 6. Here they are: 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60. We need the multiple that's 57, or almost 57. And since 57 is not on the list, it looks like 54 is the next closest thing, without being too big like 60. And to get 54, we need to have 9 6s. So we'll choose 9 as our answer. Next, we multiply 9 by 6, which we already know will give us 54 because that's what our multiplication table showed us. Now we need to subtract 54 from 57. That gives us a remainder of 3. Again, that's good because that's less than our divisor. So 57 divided by 6 equals 9 with a remainder of 3. All right, that's all for this lesson. And if you're new to division, that's plenty to get you started. It's really important to master these basic division problems that just involve one step that leaves you with a remainder. In the next video, we're going to learn how to take this basic procedure we've learned and repeat it multiple times in a process called long division. But before you move on, make sure you really practice what you've learned in this video first. Good luck, and I'll see you next time. Learn more at mathantics.com.
Okay. So he usually has a pretty good way of explaining things, and the graphics and pictures that he uses do a lot better job explaining things sometimes than I can. Let's go back here. So actually, we're going to jump over here just to talk about what we've just talked about. Okay. When we have, let me change to that. All right, so let's say we have a division problem. All right, we're going to start with something a little familiar, and then we'll move into something that's not as familiar. Okay. All right, so remember what he told us. We're moving from this division symbol to a different division symbol, okay? And sometimes people get mixed up with where to put the numbers with the other division symbol, and that's what we want to talk about for just a minute. Our other division symbol, sometimes you see this curved like that. Most of the time when I write it, it's just like that. Either one is correct, okay? When we draw this symbol, I like to say the words divided by, okay? Divided by, and that helps me. This symbol means divided by. 36 divided by 6, okay? So if I'm going to switch this to this symbol, I'm going to write it 36 divided by 6. I got a little pointy there. Didn't mean for that to happen. 36 divided by 6. And if you'll get in the habit of putting that first number inside and making that symbol around it saying divided by, it'll help you put it in the right spot. Now he told us the name of this number. Does anybody remember? Each number has,
The divisor.
it's actually not the divisor, it's the other one, the dividend, okay? One way you can remember that is to say the dividend is in the den, okay? A den is kind of like, sometimes, a bear's den is like a cave, isn't it, sort of. A den at a house might be like the living room where people sit, maybe watch TV or something. So that number is kind of inside. So think of it as a den. So the dividend is in the den. Okay, it kind of, okay. Y'all awake this morning?
Yes.
Okay, come on, it's Thursday. We're on the home stretch this week. We're on the home stretch. All right, so this is our dividend in the den. What about this guy out here?
Divisor.
Okay, that is the divisor. Okay, the divisor is on the outside. Where does our answer called that goes right here?
The quotient.
Quotient. We saw that a little bit yesterday when we were talking about division. The answer to a division problem is the quotient. Okay, so that sits up here. It kind of has this place of honor up on the top. And we know that a remainder is sometimes with it. Okay, so all these words, all these division words, but it does go with it. Okay, the dividend is in the den, the divisor is outside, the quotient sits up on top with sometimes with a remainder. Okay, let's have a test on that right now.
No. Yes. No. Yes. Yes. No. Yes.
All right, just kidding, but trying to wake you up a little bit. Okay, so you will hear me use those words. Sometimes you might hear them in a video. I do want you to be familiar with them. And the more we use them, the more you'll learn for sure what they are. Okay? So if we have this problem, we started with this a second ago. We're going to write it the other way, especially as our numbers get larger. Now this is a fact family here. We know what other number goes with this. We're going to change that in a minute where it's not. But let's start with something familiar. If we write it the other way, we've got 36 divided by 6. Okay, that's what it's going to look like. So, as our numbers get larger, guys, the array model is going to be a lot harder to do. If we have a number like 36, that's not so bad. But if that number inside of there is in the hundreds or even the thousands, because we're going to get there. Sitting there making 1,000 dots on your board or your paper is going to take quite a while. Plus, what if you lose count several times? You know, it's just not the most practical way to do it. Yeah.
I happened to make when we did that distance line thing on the 100 one.
Okay. There was a larger one on there. Just to see. And I think, was that the one that, were you dividing by 12s? Or 11s? I can't remember what the number was.
Somewhere you divided by 7, and then there was somewhere like
Okay.
12.
Now, can you, if you know no other way, can you draw an array?
Yes.
Absolutely, yes. But maybe at that point, you need to stop the dots and step into the multiplication. Okay? So, how many 6s are in 36? If you're not sure, let's say some of you are going to recognize it immediately, but let's say you've forgotten your 6s. Okay? We're going to 6 times 1, 6 times 2 is 12. Now, if you stopped there like he said on the video and I said, oh, well, 2 will fit. I know 2 will fit. I know 12. I know 12. Yes, it will. But you can get a whole lot more out of there, too. And if your number is too small, you're going to have this gigantic remainder. You can't have a remainder that's bigger than this number, because if your remainder is bigger, that means I could get a whole nother group out of there. Okay? So we're going to keep going. 6 times 3 is what, everybody? 18. 6 times 4? 24. Now, well, let's keep going, and then I'll say this. 6 times 5? 30. Okay, you know when you're getting close to kind of slow down and think a little bit. All right, this one's close. This is a maybe, but if we go one more, 6 times 6 is 36. And like I said, I know a lot of you saw that already. So this is not going to be 2, of course. This is going to be 6. Okay, if this is a 1-digit number, then I'm going to line it up with my ones place as best I can. We try to keep those numbers lined up. When we start the subtraction underneath, we try to keep everything lined up and straight, because I'll tell you something about long division problems. They get very long, and that's probably where the name comes from. Okay, so this one not so bad, but let's look at one really quick that does not come out even. If we changed this to, I guess I have to erase all of that. Let's put the 3 back. And let's say 38. Okay. Let's say it's 38 divided by 6. Okay. And we're trying to figure out how many groups of 6. You're going to hear me say this over and over. How many groups of this can I get out of this? It's like I have a big bucket of 38 something. 38 peanuts, 38 apples, and I'm trying to scoop out a group of 6 every time I scoop out. How many of those scoops of 6 can I get?
6.
Okay. I'm still going to look at my 6s. This one's pretty close, but let's check 6 times 7 just to make sure. Yeah, if you know your times tables, and you already know this is in the 40s, this is going to be too big. Okay, too big. So I'm still going to stay with 6. Now, this is what he was talking about a second ago. When you choose that number, you've got to do something with this guy and this guy right here. These two numbers are going to get multiplied together. That way you know what to subtract. What is 6 times 6?
36.
We already know it's 36. We're going to subtract that. Why are we going to subtract that? Because that's going to give us what?
Your remainder.
That's going to give us what's left. Okay. This would be remainder 2, because I cannot get another group of 6 out of 2. If for some reason I accidentally put the 5 and I subtracted 30 and I got 6 down here, I'm sorry, if I subtracted 30 and got 8 down there, then I would know, oh, wait a minute, 8. I can get another group of 6 out of that. And so I would need to change my answer. Okay. All right. We're fixing to keep going with this. Listen, I don't want anybody to get frustrated. Every now and then there's something we do, and I can tell by the looks on your face. Some of you are getting a little frustrated or just concerned about how complicated, how many steps there are. This is something that's going to take a little time for us to really get smooth at, to really get good at. So be patient with yourself. Okay? It will come. It just takes time. Okay? All right. So let me get you helping me. Okay? On your board, let's write this problem. We're going to start off writing it this way. Okay, just go ahead and write it exactly like that up at the top of your board. Okay, please stay with us because we're going to be doing lots of different steps, and I need you to stay with us. Alright, so now underneath that, let's write it the other way. We're going to write 45 divided by 4. So 45 divided by 4. Okay. You're putting that little division house around that number. You're writing divided by. Okay. We want to know how many groups of 4 we can get out of 45. This is almost a fact family, but we know it's not. 4 times something is not going to equal 45. All right, so we're going to think about our 4s. Let me back up just a second. I know this is what they had next, but this is not the best one for us to start with. Hold on just a second. I'm going to adjust this just a little bit. We're going to come back to this problem, but go ahead and erase it. Or erase part of it. We're going to change this, and you'll see why in a minute. But I got going and didn't think until just now that might not be the best one to start with. In a minute, you're going to see that problem we just had takes a little extra something, and we're not quite ready to go there. Yeah.
What's the answer? 11 remainder of 4.
We'll talk about it in a minute, because we're going to come back to it. All right. So let's change that. Sorry for the change, but get that on your board. 35 divided by 4. All right, so what would you do here? What would be the first thing you would need to start thinking? We need to start.
What's the closest you can get to 35 with 4?
We want to get as close to 35, right? With 4s. Okay? Now, I'm not going to ask you to write your 4s for every single time we do this. I'm doing this to help show you what I'm thinking. I'm thinking 4 times 1 is 4. Way too small. I'm going to keep writing. You tell me when I need to stop. Okay, just put your eyes up here for a second. Okay, so I heard stop on 4 times 8. 4 times 8 is 32. So if that's where you tell me to stop, I better check just to make sure. 4 times 9 is what, everybody?
36.
36. So I know that's too large because this is 35. It feels closer, but it's too large. Okay? So 4 times 8. How many groups of 4 can I get out of 35? Well, I can get 8 groups. So I'm going to put that 8 right there. Right now, it might not feel important why I'm putting that number in the ones place above the ones place. Later on, it's going to be very important. So just line your answer up there. Okay, what is 4 times 8? 4 times 8 is 32. So that's what I'm going to subtract. When I write that 8 up there, I'm telling you that I think 8 groups of 4 can come out of 35. So this is 8 groups of 4 right here. I need to subtract it. Okay? 5 take away 2 is
3.
3. 3 take away 3 is 0. I don't need that 0. I don't have to write it. Can I get a group of 3? Can I get a group of 4 out of 3?
No.
No, it's not big enough. Okay. And there's your answer. Okay. 8 remainder 3. All right.
Do you put it on both of the equations?
Do we put what?
Do we put the answer on both of the equations?
You can. Sometimes you're going to see me write that R with a small r, sometimes with a large R, just showing you that you can do both. Okay. Now, I want to go back to the problem we had on the board originally. Okay. So, we had 45. So, Will, in just a second, you'll see if you're right. It's not so much right now to me finding the answer, is I want you to see the process. Okay. Doing one of these problems is kind of like a journey. It's a process. Okay? And so you're fixing to see it change just a little bit right here. Okay? So if you would put the top on your marker for just a little bit. So I really need your eyes up here. This is going to add something to what we're doing. Now we just talked about how to rewrite this. We would take 45 divided by 4. Okay, so please put the top on your marker. Put your eyes up here. Okay, now when you really get into long division, you've got to stop and look at each digit sometimes. Okay, before now, like 36 divided by 6 is 6. We know our 6s. Okay, but right here, I put the brakes on just a minute ago when I saw this because I thought, oh, whoa, this has got a whole nother step in here. I could sit here and go 4 times 1, 4 times 2, 4 times 3, and get as close to 45 as I could. But I need to stop and look at this first digit right here. That first digit is a 4. Okay? I'm looking for groups of 4. So I want you to watch me work this problem. How many groups of 4 can I get out of 4? 1. Right now, I'm not going to look at it as 45 because that 4 is big enough to get a group of 4 out of it by itself. How many groups of 4 can I get out of 4? I can get 1. Now that 1 is going to go right above that 4 because I'm not even looking at the 5 right now. I'm just looking at the 4. 4 times 1, remember that it's almost like a multiplication symbol is here. 4 times 1 is 4. Okay, and I'm going to subtract that. That's going to be 0. Okay. Now when I get to that point, when I've subtracted, there's another digit sitting there. Can I just leave that? No. I have to bring it down. Okay. So we are going to draw this arrow every time. So don't even ask. Do I have to draw the arrow? Yes. Don't ask. Okay. Now I'm going to bring that 5 down. Okay. How many 4s can I get out of a 5?
1.
How many?
1 remainder.
1. Well, I'm not even worried about remainders right now. How many groups of 4 can I get out of 5?
1.
If I have 5 of something, how many times can I grab 4 out of that? 1 time. I'm going to put that 1 up above the 5 because that's what I'm dealing with. Please stop. 4 times that 1, not 4 times 11, 4 times 1. I just put another 1 up there. 4 times 1 is 4. I'm going to subtract that. 5 take away 4 is 1. Okay. Now, do I have another digit to bring down?
No.
No, so I don't have to do that anymore. I'm at the end. Can I get a group of 4 out of this?
No.
No. So that is my remainder. Okay. So, were you right about the answer? Yes. But more importantly, I need you to see how this process works. What we just did, hold on just one second. What we just did is kind of break this apart. And we were able to look at it in smaller chunks. We didn't have to go 45. Okay, 4 times 1, 4 times 2, 4 times 3, 4 times 4. We took it in small chunks. We looked at this piece, and then we looked at this piece. Okay? And so in some ways, doing it this way is easier. Because what if we had this for a problem? Okay, everybody, use the multiplication way. Okay, 6 times 1, 6 times 2. Sorry, I'm going to be here a while. 6 times 47, 6 times 48, 6 times 573. I'm kidding. But you'd be here a while. You know, you'd be here a while. And so if we do it the other way, the long division way, you get to stop at each number. Can I get a group of 6 out of 7?
Yes.
Yes. How many?
1.
Just 1. So I'm going to put that 1 right above the 7. 6 times 1 is 6. I'm just going to subtract right there right now. I don't have to worry about this ginormous number. I just have to worry about a little part of it. So I'm going to get a 1, right? Okay. Now we're not here yet. I'm just showing this to you. Okay. Now I'm ready to bring the next digit down. And look at there. Now all I have to worry about is a 14. I don't have to worry about the 2 yet. How many 6s can I get out of 14? Well, that's pretty easy. 6 times 1, 6 times 2 is what? 12. But 6 times 3 is 18. Too big, too big. Go back to 6 times 2. So I'm going to put my 2 right there. You can see I'm right here. 6 times 2 is 12. And I'm just going to subtract that. See, this makes the subtraction smaller. It makes the multiplication smaller. We're just dealing with pieces of this number at a time. So when I subtract that, I get 2. Now I'm ready. Look, your arrow is going to get longer each time you bring a digit down. Now I'm going to bring that 2 down right here. It's kind of pretty when you're finished. You've got all these arrows. Okay? Anyway, didn't know math could be pretty, did you? How many 6s can I get out of 22? Think about your 6s. Now this is where you might need to go. All right, 6 times 1, 6 times 2, 6 times 3, 6 times 4. What is 6 times 4?
24.
24. It's too big. Let's go back. 6 times 3? 18. Let's go there. So I'm going to put 3. 6 times 3 is 18. All right, what do I get when I subtract those 2?
4.
4. Let's double check him, but he's correct. 12 take away 8 is 4. Can I get another group of 6 out of 4? No. That's a pretty, that remainder is a little larger than we're used to, but it's, as long as I can't get another group of this out, it's fine. So my remainder, I'll move these out of the way. My remainder is 4. 1, 2, 3, 4. Couldn't have planned that any better. Okay. Now, this is long division. Okay. We have this little thing that we use to remember the steps. And I'm going to hang it up. We'll talk about it. We'll say it lots of times. Okay. But it's like our little division. Well, okay then. Little division family.
Yeah.
It's a strong movement. Daddy, mama, sister, brother. Daddy, mama, sister, brother. Okay. At first you divide. How many 6s can I get out of this number? Then you multiply. Mama means multiply. 6 times 1 gave me my 6. Then I subtract. Sister, subtract. You subtracted. And then brother is bring it on down. Okay? And we bring down the next digit. I might have a number that has 7 more digits in it. I just keep going. I just keep doing the same thing. My arrows are just going to get longer and longer as I go. Okay? So again, if this seems confusing right now, we're going to do it lots of times. It's going to get clearer and clearer how to do it. Okay? One more thing I wanted to show you before we take a quick break. What was it? What was it? What was it? It just went blank. Let's back up here. Daddy, Mom, Sister, Brother. I hate it when I forget something. Okay. All right. I don't remember what it was. I tell you what. Let's do one quick one together. We won't do a long one. We'll just do a quick one together. Oh, I know what it was. I know what it was. Let's skip that. I'll save that for later. Let's do one quick one together, and then we'll take a break, come back, and practice just a little bit more. All right, so let's do this problem right here. 68 divided by 3. Okay. So put that on your board. Okay, now let's do this. Let's get in this habit. And I'm sorry if you're having to erase, but we haven't done much. I want you to turn your board this way. Get in that habit with division because sometimes our problems get long this way. Okay, so just turn your board. And we're going to write it over 68 divided by 3. I want you to get used to seeing that what this was is now this. Okay, 68 divided by 3. Get that on your board. So if we're thinking of our division family, Daddy, Mama, Sister, Brother, we're going to divide first.
Daddy's first.
Okay. How many 3s can I get out of a 6? We're going to, okay, because this is big enough to get some 3s out of it. I don't have to look at the whole number first. Somebody said it.
2.
Okay, when we see a 6 and a 3, we know that 2 is what's missing. 6 times 2. Sorry, 3 times 2. You can put that little multiplication symbol right there to help you remember. 3 times 2 is what?
6.
That's what we're going to subtract. We're going to put it right under the 6. Do not put it under the 8. What? When we've done subtraction, every time up until now, we've had to line up our numbers over here, haven't we?
Yes.
Okay. Is this really a 6 I'm subtracting?
No.
It's really not. Okay? Because I've written it in the tens place. It's really 6 times 20, isn't it? Okay? And that's why we're writing it over here. Okay? All right. So 6 times 6, everybody, real tough one. What is it?
36.
Did I just say 6 times 6? Man, y'all are good. Because I was looking at this and I said 6 times 6. 6 minus 6 is what I meant to say.
0.
There you go. Sorry about that. Okay. Now, keep these really straight and lined up. That's important. Okay? Go ahead and do that if you haven't. 6 minus 6 is 0. That was simple. That was simple subtraction. When we do the long division method, it helps us break down things into smaller chunks. Okay? So we have done Daddy. We've done Mama multiply. We've done Sister subtract. Now we're ready to do Brother bring it on down. So we're going to draw an arrow under the 8 to right there, and then draw the 8 beside that 0. Okay, so.
It's going to be 2.
Okay. Now all we have to ask ourselves is how many 3s can I get out of 8? See, we're keeping it small by doing it this way.
2.
3 times 2 is what?
6.
6, but 3 times 3 is
9.
9, too big. Okay, so 3 times 2. 3 times 2, Martin said, is 6, so we're going to subtract 6. What do we get when we subtract 6 from 8? 2. Can I get another group of 3 out of 2?
No.
Nope. It's too small. So Brandon, this 2 is going to become my what?
Remainder.
My remainder. It's left over. I cannot get another group of 3. So it's my leftovers. It's my remainder. 22, remainder 2.
Oh my God.
Okay, remainder doesn't get written down here. Remainder has to be up here with the answer. Okay, your entire answer has to be up here at the top or it won't be seen or counted. Okay, the division problem answer needs to be up there on the top. Okay. Yes.
We used to get these problems on AM in 3rd grade, but they weren't big numbers.
All this is doing in 4th grade is getting a little larger. And when it gets larger, it gets large enough where we need to start breaking it down into smaller chunks with this way we're doing it. Okay? So, because of that, I didn't have to stand here and go, how 3 times something equals 68. I could have, but it would have taken me a little while. Guys, you won't believe, from right now, I'm watching you. You're in the middle of trying to just figure out what is Miss Wendy talking about today. In another several days, you guys are going to be flying through some of these problems. It doesn't feel like it right now, but it's coming. And you're going to get more comfortable with this. You're going to get faster at this. It's going to become just a whole lot easier to do. Okay? You might be sitting there going, no, it ain't. No, it isn't. It will. It will. Okay? We just got to get more comfortable with knowing what steps to take. Okay, let's put everything down. Put the tops on your markers. We are not quite ready for our book, so let's leave this on our desk and let's go ahead and line up. We'll take a restroom break. Okay. And we'll come on back. Grab that. Grab that.
2 times 2. I said a billion times 2. Pretty much all you do is a billion. All you do is a billion. I don't know if you That's what it's times 2. You see, 2 billion. 2 billion times. So, what do we have to do? Then it'll be 4 billion. That's exactly what I said. Huh? Nothing. You got a lot to do.
Yeah, Mark, we got a lot to do. I think they've already done 8 problems.
Yeah, we already did it.
Totally. Yeah. I totally believe that.
I still got so
I went to my dad's house and he has a whole container of fish bones, and I washed them in the sink.
While we're waiting, would you go ahead and clear off your board? We're gonna do at least one more practice problem.
We have a whole container of railway spices. That's easy and we
Okay.
Oh, that's easy.
All right, before we do this last practice problem, go ahead and put the top on your marker. I want to show you something. The top's on your marker so they're not drying out. Okay. What happens, I'm kind of getting ahead of where we need to be today, but that's okay. It's okay for us to go ahead and see this. Let's say, well, no, you know what? We really don't need that today. We'll take that step tomorrow. Trying to find a good one that's the right size for us today. Let's look at all right, let's write this on our board. We're going to go ahead and write this. This is, now what if you had to write this the other way? Well, no, what I mean is with the other division symbol. A lot of people would want to go 3, the division symbol of 74. That is not correct. Because that says 3 divided by 74. This says 74 divided by 3. And they are different. It's not like multiplication where you can change the numbers around. Okay? This would look like 74 divided by 3. Okay? But what I want you to have on your board right now is this. Okay? Now, I have walked you through this, and guys, for the next several days, anybody in here learn to ride a bike? Y'all ride bikes? Okay.
Yes, of course.
You remember, I figured. But you know, do you remember learning that, and it's like, at first, you did not want whoever was helping you to let go of that bike?
Yeah.
Because you didn't feel like you had your balance just right? And you could feel yourself leaning at times like, please don't let me go. Okay. I'm not going to let go of you for a while. Now, some of you might be ready to fly, but most of us are not. And so I'm not going to totally let go of you and make you do something like this totally on your own. Okay? Our problem set is going to have much smaller numbers. You're going to feel more comfortable with our problem set. I kind of stretched us a little bit today by giving us this, and that's okay. All right, so what I do want you to do, I'm going to do it with you. However, I want you to try to tell me what I need to do. Let's see what you remember from me telling you the steps instead of me just always saying it. So what do you remember? What do you think we would look at or do first? Yeah.
3 divided by 7.
Okay, we're trying to figure out right now at first just how many 3's we can get out of 7. That's 7 divided by 3. All right, think about your 3's. Think about how close I can get without getting too big. Okay. Faith?
2,
3 times 2 is what?
6,
6 is very close to 7. 3 times 3 is what?
9.
9. Way too big. Okay, let's turn around. So 3 times 2 would be it. 3 times 2 is what? 6. We're going to subtract 6. Just from the 7, we're going to subtract that 6. Guys, you're with me. Okay? Just stay with me. Okay, so make sure your board has what I've got. Okay, what goes right above that 7 on the answer line? The 2. Okay, make sure you've got that up there. And up here. Okay. Part of this is learning where to put everything. You know, we've got a brand new symbol. We've got places to put things. It's kind of weird at first, but like I said, it becomes a lot more normal as we go. 7 take away 6, everybody. 1. Now what do I do next? We have divided, Daddy divided, we have Mama multiplied, we have Sister subtracted. Now what do we do?
You subtract 1. We do an arrow from the 4.
We draw an arrow from the 4. Because Alexandra, what are we doing? We are bringing it down, brother, bringing it down. So now that 1, which is really a 10 because it's in the tens place, and those 4 1s become 14. Okay. So how many 3s can I get out of 14? Brandon, let's think. Let's think about our 3. 3 times what do you think would be close to 14? Everybody's thinking. Okay. When I do my 3s, how can I get, how many 3s would get me close to 14?
4.
3 times 4 is what?
12.
Okay, 3 times 4 is 12. So I always like to check one more. 3 times 5 is what?
20.
15.
15.
No,
15.
15.
Okay.
What are you?
50.
What?
This is what I did last year. They would make me mad. Like, they'd forget their multiplication. I'd like one horn and come out. You got one wrong, then you got another one wrong. The bull, the... Who said a wrong multiplication fact?
It's Miss
I'm just
Wendy
kidding.
the bull. You gotta
All right.
cut somebody out by the end of the year.
No, because by then we're not going to mess them up. Okay, so Brandon's right. 3 times 4 is going to get us the closest without going over. So 3 times 4 is 12. We're going to subtract that and get 2. Okay. 2 is too small to get another group of 3. So it is our remainder. Okay. All right. All right, go ahead and put your boards all the way away. Clear them off. We're going to look at a few of the concept problems just so we know what we're dealing with. Okay. This is pretty heavy. I know your brains are going to be tired after this.
5 times 6 is 35.
5 times 6 is 34.
You know, we can either do this or the Incredible Hulk. Like, you get it wrong, this arm goes zoom, and it's like muscle and green, and someone else gets it wrong, like zoom.
Wendy has some big muscles.
Then the head gets, all green. And slowly, she's turning into, she's half Hulk, half, Yeah.
Wait, how many times before
Is there an Incredible Hulk one? I don't either. Okay. Lay out your book, but just keep it closed for a second. Okay, and you're ready in 5, 4, this road. 3, 2.5.
Teachers are counting. I don't want to get to 1.
Trying to help you out here. Okay, so you're gonna see some problems are very tiny. How many 2s can we get out of 7? Okay, I'm not even gonna really go to that one because I think we can figure that out. You might see boxes like this. Check your work. That's gonna become really valuable to us later on, especially when we have a large number under here and we want to make sure we've done all this hard work correctly. You can multiply to find your answer. So they're just kind of cluing you into that fact. Okay. When we get a little further, we've got 27 divided by 2. Okay. 27 divided by 2. Are we ready to try this on our own? That's my question.
No.
Yes.
No.
Okay.
No.
Okay.
No.
Yes.
Okay.
No.
One time's enough. Okay. One time's enough. Let me just double check how. Some are small, some are 2-digit numbers.
I think we should just try it.
I do want you to try it. I am going to say this. We're going to try this. We are not doing our exit ticket today because this is when we sometimes start something brand new and it's this much of a jump. I'm not ready for us to do that. Okay. Let's give this a try and just see. Would it be helpful if this one's up here. Okay. Use these steps. Let that remind you of what to do. This is going to start on page. Never I have the page number unless I have a book like yours. 81. Okay, this is the problem set for 16. What I'm wanting to double check is just how many of these we're doing. Like the way I was going to think. There's not that many because they're so spread out. Okay. We are gonna. I want you to try to get to all of them because really, 1, 2, 3, 4, 5, 6. There's 6 of them. Okay. Okay. And if you get finished with those 6, then you can keep going. So you're gonna start on page 81 and go all the way to 83. So you may go ahead and get started with that.